We have talked about how the particles in a substance are always moving. You may, at some point, have observed that if you heat a substance, the particles start moving faster. We can measure the kinetic energy associated with these particles with a thermometer. When particles in a substance collide with the thermometer, they transfer their energy to the thermometer. The particles in the thermometer speed up and expand and collide with the particles in the alcohol inside the thermometer. These particles speed up and expand and rise in the tube. The thermometer is then calibrated to show a certain change as the alcohol expands. And this is how we measure our temperature. In the United States, the Fahrenheit scale is the primary scale used to measure temperature. Daniel Fahrenheit created a mixture of water, ice, and ammonium chloride, and made this temperature his zero mark. He created another point on his scale, 32 degrees Fahrenheit, by using just a mixture of ice and water. The third point on his scale, 98 degrees Fahrenheit, was human body temperature. From those 3 points, he created a scale that we now use as Fahrenheit. Most common everywhere else is the Celsius scale. Anders Celsius based his scale on the freezing and boiling point of water. So in Celsius, 0 degrees is the freezing point of water, and 100 degrees is the boiling point. Converting between Fahrenheit and Celsius is really not that convenient, but it can be done. While the Celsius and Fahrenheit scale are appropriate for use for every day, when we think about what is actually the working definition of temperature, we see that it really cannot hold up. Temperature is technically the average kinetic energy of the particles in a substance. So in theory, 0 degrees Celsius should mean that we have zero kinetic energy. We regularly take our temperatures below the freezing point of water, so we needed to come up with an absolute temperature scale in order to reconcile those numbers with our definition. On the Kelvin scale, 0 Kelvin is the lowest possible temperature that can be obtained. At this point, referred to as absolute zero, the particles would have zero kinetic energy. The gradations of a Kelvin scale are equal to the gradations on the Celsius scale. This means that an increase of 1 degree Celsius is also an increase in 1 degree Kelvin. Studies have shown that absolute zero would occur at negative 273.150 degrees Celsius. So in order to convert a Celsius temperature to Kelvin, you would simply need to add 273.15. Room temperature is generally described as 25 degrees Celsius. What if we wanted to know this temperature in degrees Fahrenheit, or in Kelvin? A Celsius degree is not the same size as a Fahrenheit degree. In fact, if you increase 1 degree Fahrenheit, you actually increase 9/5 degrees Celsius. We also know that freezing water in degrees Celsius is 0, and at Fahrenheit it is 32. So to account for this, we have to add 32 to our Celsius temperature. So if our Celsius temperature is 25 degrees Celsius, we simply take 9 divided by 5, multiplied by 25. To this value, we add 32. That will give us 77 degrees Fahrenheit. Now for Kelvin, all we have to do is add 273.15 to our 25 degrees Celsius. This gives us a Kelvin temperature of 298. Notice that when we write a temperature in Kelvin, we do not use a degree sign. One of the catches in using a thermometer is that the liquid that is expanding is not actually in contact with the substance it is measuring. It is actually expanding because of the temperature of the thermometer itself. Luckily, we don't have to worry too much, however, because of what is known as thermal equilibrium. When two objects come in contact, heat flows from the hotter object to the cooler object. This will happen until both substances are at the same temperature. If you add in a third object, all three of them will reach thermal equilibrium together. When we choose the bulb of our thermometer, we choose a substance that really conducts heat and allows that heat transfer to occur efficiently. This is what actually allows us to produce the thermometers and measure the temperature of whatever substance it is, based on the expansion of the liquid inside that thermometer.